To add or subtract rational expressions, we're going to need a common denominator. An example where we're going to focus on adding instead of subtracting. But the goal is, for this very first problem, what is the common denominator if our two denominators are x plus 5 and x plus 2? The question to ask is, are there any common factors between those two denominators? For this problem, I want to go back to, well, how would you add something like 1/5 and a half? Since 5 and 2 do not share any common denominators, the least common denominator is going to be 10, the product of the two. So what I'm going to do is take 1/5 and multiply in the number that I want, which is 2. But I also have to do that to the numerator as well. For the second fraction, which is a half, the factor that is missing is a 5, so I'm going to multiply it in, but I want to make sure I do the same thing to the top as well. So if I were to complete this problem, it's really 2/10 plus 5/10, and the answer is 7/10. Let's use this idea to add these two fractions together. So to start with, I need the least common denominator, and it is simply the product of x plus 5 and x plus 2. And I'm going to leave it just like this. So I'll take my first fraction, and note that, well, I'm missing the x plus 2, so I have to multiply it in. I just want to make sure that I also multiply it to the numerator. For the second fraction, I'm missing the x plus 5, so I'm going to multiply it in. But I want to do it to the numerator as well. So even though it looks a little bit more abstract, it's analogous to what I did up here. I figured out my common denominator and multiplied in the factors that I needed to make this work. Okay, going back here, my second step is going to be to combine this into one fraction. So I'm going to multiply the numerators together and then multiply the denominators together. The denominator I'm going to leave as x plus 5 times x plus 2. And the numerator is going to be x times x plus 2, which is x squared plus 2x. You have to distribute the x to both terms. For the second fraction, again, I have my common denominator, which I'll write as x plus 5 times x plus 2. And in the numerator, I multiply the 4 to the x plus 5, and I get 4x plus 20. Since I have a common denominator, I can now put this into one fraction by adding the numerators together. In the numerator, I have x squared. I'm adding a 2x and a 4x, which I'll put as 6x. And then I have plus 20. This is the answer to the problem. So the hard part of this problem is going to be, what is my common denominator? But once you figure it out, you can simply multiply in what you need to create your common denominator. So let's compare this to 5 divided by x squared minus 16 plus 3 over x plus 4. Again, the idea is, are there any common factors between these two denominators? So I'm actually going to factor this apart. I'm going to take this problem. The first denominator is a little bit more complicated than the one we just did. It's x squared minus 16, which is a difference of two squares. That is x minus 4 times x plus 4. I cannot factor the second denominator. It's just x plus 4. What is the least common denominator for these two fractions? I see that if I had an x minus 4 over here, the denominator would be exactly the same as the one that sits over here. So thinking ahead, I know what I need to incorporate. I'd like to multiply this x minus 4 into the problem. It's just I have to do the same thing to the numerator as well. And once I do, my two denominators are now the same. Said another way, my least common denominator is x minus 4 times x plus 4. You can really just ask yourself what's missing, and whatever is missing, you can multiply it in. So continuing, the very first fraction I didn't do anything to. It was just 5 over x minus 4 times x plus 4. I just factored it. And in my second fraction, I'm going to distribute the 3 to the x minus 4, giving me 3x minus 12. But my denominator, I'll leave as x minus 4 times x plus 4. Since I now have a common denominator, I can write this as one fraction and simply add the two numerators together. I have 3x. I have this minus 12, so it's really 5 plus a negative 12. That gives me negative 7. And this is the final answer. So just comparing these two examples, there were no common factors. We could simply multiply them together. Here, well, there was an x plus 4 in both. And I just asked myself what was missing. And what was missing, I multiplied in. Let's now look at an example where we subtract two rational expressions. It'll be similar to adding them. We just have to be careful about perhaps distributing a negative number. Okay, starting with the least common denominator, I'm going to put in this step where I factor the denominators. The first fraction is x plus 2 divided by, and I have, well, if I take out an x, I get x times x squared minus 1 minus 3. Okay, x squared plus 3x plus 2, that is x plus 1 and x plus 2, okay. Product is 2, the sum is 3. I still can't see what the least common denominator is, but that's only because I have a potential factor coming from this x squared minus 1. So I don't know if there's any common factors yet, because this is not completely factored. Let's take it one step further. I'm going to take the first fraction, and x squared minus 1 is a difference of two squares. I could write that as x times x minus 1 times x plus 1. And then my other fraction is 3 times x minus 1 times, x plus 1 times x plus 2. Everything is factored. I can now see what is missing between the two denominators. For my least common denominator, I have to have an x, so I'll put x. I have to have an x minus 1, so I need that. I also need an x plus 1. I can see that's common between the two denominators, so I need an x plus 1. But I also need an x plus 2. So it's kind of a lot going on with the least common denominator, but that's the smallest amount that's going to work for these two fractions. I'm going to copy this part down again, leave some space where I can multiply in the necessary factors. So for the first fraction, I have x plus 2 divided by x times x minus 1 times x plus 1. Again, I want to leave a little space here and ask myself, what is missing? If I had an x plus 2, that means I could make the denominators the same. So I want to have that in the numerator as well. For the second fraction, so I want minus 3 over x plus 1 times x plus 2, and what is missing is I need an x and also an x minus 1. I now have a common denominator. I'm going to write this as one fraction. This is, like a giant mess here so far, but just to kind of clean this up, I multiply the numerators, so it's going to be x plus 2 times x plus 2. I'll be careful to use some parentheses. Now I'm going to subtract the product of 3 times x minus 1. 3 times x minus 1. And this is all over my common denominator of x times x minus 1 times x plus 1 times x plus 2. And at this point, we're really close to done. The rest is just leaving the denominator alone. I'm going to multiply this stuff together. I'll distribute this negative 3x into these parentheses and combine like terms. So that is x plus 2 times x plus 2 is x squared plus 4x plus 4, minus, if I distribute in a 3x, I get 3x squared plus 3x, all over x times x minus 1 times x plus 1 times x plus 2. And I just need to combine any like terms. I have x squared minus 3x squared. That's a minus 2x squared. Okay, I have a positive 4x and a positive 3x. That is a positive 7x. And then lastly, I have a plus 4. Again, all divided by my common denominator, x times x minus 1 times x plus 1 times x plus 2. And I think this is a reasonable place to stop, where, yes, you could multiply all this together. I don't think there's much benefit to doing that, and that's it.